All right, so I am live again, still making things on time mostly, and it is episode 4 of 52 weeks of AWS. And believe it or not, today is probably the most amount of material I've had yet. There's so much material, it's going to be hard to cover all of it, but I'll do my best. A little bit of a recap about what this is if you're listening from an audio podcast, maybe driving somewhere. So my name is Noah Gift, and I do a lot of work with AWS. I'm currently writing a book for O'Reilly called C# on AWS, and it's going to cover basically for a .NET developer how to get started with developing on AWS. And I'll talk a little bit about some of the things I'm currently working on and some of the ideas about some of the things I'm working on in the book. I'm also an AWS ML hero, so I promote AWS machine learning. I'm an evangelist for that, and I teach at multiple universities. And I also do a lot of content authoring for platforms like Coursera and O'Reilly. And so really I'm fairly prolific in creating content around cloud computing, machine learning, ML ops. And the idea with this podcast is to just share whatever I'm working on this every week, because there's just so many new things that are cropping up. I figured I'd just give a brain dump, and hopefully this will be a podcast that you can listen to when you're driving, or if you're watching live, you can actually, see some of the material. Either one, you should get some value out of it. But the idea is that you level up by listening to the material that we cover. So let's go ahead and get started. Okay, so I'm back here. I just had to drop out for a second there to share my screen. I'm going to go ahead and share my screen. Yeah, I'm doing this live stream / podcast on a new MacBook Pro, which is pretty shocking actually how powerful it is. And I'll share a little bit about some of the things I've been doing as well, which I think will be interesting to people. So let's see here. We got let's see, AWS Bootcamp. This looks pretty good. There we go. Yeah, this is what I want to share. Perfect. Okay, so I got this thing shared up here. Again, episode 4. The first thing, I'm just going to talk about some of the stuff I've been working on, and I'll just cover that first because I think it could be interesting. So first up, benchmarking. I already created a video for this, and if you want to look at this repo, Noah Gift, benchmarking / or -AWS, you can see more information about it. But one of the things I was taking a look at for the book I'm writing is just how would you benchmark things on AWS? And in particular, I think the Sysbench tool is a great tool if you're looking for an open source tool that doesn't cost any money and you want to do some basic benchmarking. And one of the things I discovered was that you can actually build out incredibly powerful benchmarks by using the large instances. And one of the things I discovered was that this AWS M5 24X large machine here, which has 96 cores, is really got staggering performance. So one of the things that you may be wondering, for example, is if you spin up a virtual machine that's got 1 or 4 cores, like in the case of GitHub Codespaces or an AWS Micro, what are you really getting in terms of bang for your buck? Well, I enumerate this very clearly right in this benchmark here. You can see that like a 4-core machine from GitHub Codespaces, which again is great. It's a great, powerful machine. You can do about 3,300 events per events in about 10 seconds. But in terms of the machine here, the total amount of events you could do in 10 seconds, the 96 core was 820,000. So you can see we're talking 100, over, what would it be, like 200x, 250x performance by using these large machines. So if you are doing parallel processing, this is really where AWS comes in handy. And again, I would recommend you do benchmarking. You can take a look at this repo if you want to get a little more information. One of the things that I'll mention here that I think is kind of interesting is that I'll bring up another sheet here that I was doing in terms of benchmarking. Let's go ahead and get this thing up. And one of the things that's kind of cool is I also had a little bit of time to benchmark the MacBook Pro, the newest one, which is the 16-inch Apple M1 Max. And I was pretty shocked actually about what I discovered. And I'm going to just pull this in here so you can see the thing I was shocked about. So basically what I discovered was that while it's true that there are some, you get a 200 to 250x performance by using a 96 core machine on AWS, believe it or not, a 10 core machine, a MacBook Pro, blew it out of the water by another, let's say, 7 times, because I was able to get 6.8 million events in this 10 seconds window here from Sysbench. So this is one of the things that's just truly shocking about MacBook Pro is the speed that this laptop has. In fact, it's 7 times more powerful, at least in this CPU benchmark. It's 7 times more powerful, even though it's a 10 core machine, than essentially a 100 core machine in the cloud. So if you were wondering about whether it's a good development machine, I think this metric might be something to take a look at. And again, you can recreate it on your own, but it's just an amazing machine in general. Okay, so the next thing that I was going to take a look at here was history of AWS. So one of the things I'm writing in the AWS C# book is a section that talks a little bit about, why do you care about AWS? What's the reason for using AWS? And one of the ways that I'm going to explain this is I'm going to talk about the shareholder letter. And in particular, if you haven't read these letters, I think they're very interesting because there's some things that have been there from the very beginning, since, for example, 1997. And let's just read through a little bit of what is put in the 2020. So it includes a little bit of the 1997 letter. So it says, to our shareholders, and this is from Jeff Bezos, in Amazon's 1997 letter to shareholders, I talked about the hope of creating a franchise, one that would reinvent what it means to serve customers by unlocking the internet's power. I've noted that Amazon has grown from 158 employees to 614, and we've had 1.5 million accounts. We had just gone public at a day split price of $150 per share. I wrote that on day one. So that's basically, in 1997, day one, they're talking about, how they had $1.50 per share. Since then, they've gone a long way. They have 500,000 people employed, and there's 1.3 million around the world, and there's 200 million Prime members, 1.9 million small and medium-sized businesses sell in the store, and the small businesses actually are 60% of the sales, and customers have connected 800 million smart devices to Alexa, and Amazon Web Services serve millions of customers with a 50 billion annualized run rate. In 97, there was in Prime, Marketplace, Alexa, AWS. So along the way, they've created 1.6 trillion of wealth for shareholders. So that is pretty cool that the shareholders of Amazon have been able to benefit, not just the owners themselves, and the founders of the company. And there's some stories about people, using the money to build things. And then just a few other things here that they mention is, create more than you consume, which I think is actually a very good idea. And then a few other things here that I think are interesting is that, with AWS in particular, one of the things that they're doing is that they're dividing up the customer value creation. So shareholders, employees, third-party sellers, and they're showing that they were able to create in 2020 164 billion in customer value creation. So I do like this idea of thinking about externalities, where you're actually thinking about what you're doing in terms of a impact on the world. And then I think a few other things here that are important to talk about is that they're acknowledging that they could do a little bit better in terms of some of their processes of managing employees. And so that's one of their goals now, is to make Amazon the best employer and the safest place to work. And in particular, one of the things I think you'll see, and I won't go through the whole shareholder letter, but I'd recommend you go through it, is that basically Amazon is always trying to improve, always trying to, continuously make things better, and also be aware of their own mistakes. So have high degrees of metacognition. So I think that's one of the real stories with Amazon, is be aware what you don't know, what you do know, and constantly try to create innovation and best practices. And they have the Amazon values, I think, and this would be a good thing to mention real quick, is Amazon values. And if we look at this, they have this thing called the leadership principles. And I think they are pretty interesting in terms of leadership principles. And I think they do separate in themselves from other companies because of some of these principles. So customer obsession, I think, is a really important one. I mean, ultimately, that's why I like using the AWS cloud more than other clouds, is that they do have a customer obsession, and I feel confident that they'll make me happy with what I'm doing. And even when I was running companies that were using AWS, I was always confident that they were going to have my back. Ownership. So, people in Amazon should act as owners, which I also believe in. Invent and simplify. So I think this is another important one, is that, people need to be aware that one of their goals is to reduce the complexity of workflows. And I think you see this in many organizations that have high degrees of bureaucracy. And I think this is one of the reasons why I like Amazon as well. People are right a lot. So, you have to have good judgment and good instincts, and then back up your ideas, learn and be curious, hire and develop the best, make sure that you're hiring good people, insist on the highest standards. I think this is a very interesting one that we see a lot, unfortunately. There's both good and bad government. Some of the things I've seen in government is when people don't have high standards, like in cities, many cities are not having high standards. That's when you get yourself into trouble. And so I think that's one of the easy ways to fix cities in America is to have high standards. Either you have standards or you don't. And if you don't have standards, you have problems. That's why I think this leadership principle is such a good one. Think big, right? If you're thinking small, it's a self-fulfilling prophecy. And bias for action. I think one of the ones I really agree with the most in terms of their leadership principles is this bias for action. I personally do this with my life, is I have a bias for action. If I'm, the choices are don't do anything and just do analysis, or do something where maybe it's not perfect, I go for a bias for action. And I think this is really an important thing for many people to have. And then frugality, right? Which is, if you always think you should blow all your money, you're going to blow all your money. If you try to be frugal, you're going to be a lot more efficient, earn trust, dive deep, have backbone, disagree and commit. I think there's another one that's a real problem with many organizations because of bureaucracy. They want to make their middle manager happy, and their middle manager wants to get more power. And I think you must have this kind of structure in your company. And then finally, deliver results. I mean, ultimately, I think that's one of the biggest things that people are lacking in their careers or in other companies. Is it's pretty simple. It's, are you delivering results or not? The reasons why you didn't deliver results really ultimately don't matter. And I think, again, if we look at, in particular, the cities of America that are struggling, I think one of the things that they're lacking, in terms of results, they're not delivering, right? They're not delivering results. I could see other parts of America as well that I believe could be better. Like, for example, healthcare, education. It's really simple. You need to deliver results. And if you don't deliver results, you need to fix your system so you can deliver results. The other one I think is really a good one that they're adding as well, which is strive to be the Earth's best employer. And, in particular, I do think there is going to be a backlash against technology companies because they have been a little shifted towards just ignoring the externalities of your employees, what you're doing to the environment, what you're doing to other people that aren't using your product. For example, with self-driving cars, people that are just walking across the street, they didn't ask to be put into an experiment where a car may hit them, right? That's a negative externality. And those kind of things, or, people didn't choose to be in an experiment where social media gave them, misinformation or disinformation. Even if they're not on social media, they're still going to be those things that happen in the real world, like, people that won't get vaccines or won't wear masks or do preventative things. Those kind of problems are going to crop up if you ignore negative externalities. And I think this is really a trend that we're going to see, where this is a great thing that AWS is doing, and I want to give them a thumbs up for it. And I think many organizations, if you're a startup or you're a Fortune 500 company, I think you can blow the tires off other companies if you think about what I call organic technology, which is you be better than your competitors in terms of not trying to be politically correct, but try to actually make the world a better place and not exploit people. And so, anyway, to make a long story short, I really like these leadership principles. I think they're great. And so I'm going to put these into the chapter and talk about, some of this material. Okay, next up here, the other thing I want to talk about is the Visual Studio AWS tool. And so I'm going to just share this real quick here. And I'm going to share basically a VM that I got running inside of my Mac here, which is ridiculously powerful. So I feel good at running this VM. And I'm going to go ahead and share this out real quick. And one of the things I think that's kind of interesting, if we take a look at this Visual Studio environment here, is even if you're not a Windows person, which I really am not really a Windows person, but one of the things I do like is C#. I think is a pretty cool language. I like the performance alone is a very good reason to use C#. But the other thing is the tooling, right? And so with Visual Studio, which you can install the Community Edition on Windows 11 or Windows 10, what's awesome about it is if you install the AWS toolkit, you can do things you can't do, believe it or not, with the console of AWS. And a great example would be, here we see on the left here, we've got CloudFront, EC2, S3, SNS. You can start just right-clicking on things and do really cool stuff. So let's say I want to go to S3 right here, right? And look, I have all my buckets. And in fact, I can just take some project, like I know this is an old bucket of mine. If I right-click on it, look, I can just say delete, and it'll actually delete the bucket and all the objects for me. The bucket doesn't exist. But basically, you can actually go through here and do all these really powerful actions here by just right-clicking on things. In particular, another thing you can do is you can go to EC2 and you can go to instances, and you can also go take a look at all your current running instances, do something like stop them, or you could actually right-click and say launch an instance as well. So really, in my opinion, it's actually much more efficient than the regular console. I mean, the console is not bad, but this is a lot better and more clean. And even if you're not doing C# development, it's worth kicking the tires on it and seeing if potentially this is a tool that can augment what you're already doing in terms of orchestrating things on the AWS platform. So that was just one thing I wanted to share real quick. The next thing I'm going to share with you is that, as I mentioned, I have a lot of stuff to share today, is that I was also playing around with how would you teach someone how to get started with C# if they weren't, let's say, a Windows person and they wanted to just start playing around with C# here. Again, maybe in preparation to later go to AWS. Well, one of the things that's really awesome is that you can actually, essentially build out an entire ecosystem inside of by using GitHub Codespaces. So what I'm going to do here is I'm going to go to here, and I'm going to go to my Codespaces right here, and I'm going to show you. Here we go, hello.net Codespaces. And if we take a look at this thing, what's kind of cool about it is you can see I did an F# and a hello world Codespace inside of here. And in a nutshell here, we can just launch this, and I'll just show you why it's so cool, is that because it comes with .NET command line tool already, you can use it as a full-fledged development environment, and you can actually start developing C# for free. You don't need any editors or any other software. And in particular, let's just go into one of these projects that I was working on. Here's one. Actually, I'm going to change this to dark mode because I really hate light mode. Let's go to Visual Studio Dark. There we go. Way better. So let's go into F# here. So you can see here's an F# program, and if I want to run it, I just say .NET run, and it goes through and executes my code. If I want to create a new project, it's pretty simple. I can just go through here and make a new one and say .NET new console-in, and we can say, like, I don't know, 52 weeks AWS, something like this. And then what's cool about it is, notice what happens is it goes through here and it creates this whole structure for me so I can run my code. And then if I want to just CD into this, all I need to do is just basically tweak it and change it however I want to do it. I'll just say hello world, 52 weeks AWS. And then from here, I can just do the same thing. I could just say .NET. I can just use up arrow, .NET run, boom, there we go. So pretty much trivial to build C# code inside of GitHub code spaces as well. So again, if you want to play around with doing a little bit of C#, you may want to have a couple tools. One, if you want to use AWS, one is use GitHub code spaces, and the other one is use Windows 11. And why not have a little bit of both and see which one works for which situation you're in. I'm a huge fan of using multiple tools at the same time. All right, so we got a lot done there, and I'm going to move on now to AWS CP Part 2. So what we can do is I'm going to go over to these slides here, and let's take a look at where I left off. So here we go. I believe I left off on Module 3. So we probably could get through maybe, this might take us three. This we might have to divide this into 3 parts. So let's see if I can get, let's just double check Module 3 here. I believe that's what I covered last time. No, we covered module. I believe we covered module 2 last time. We didn't get into module 3 here. Let's just double check where we're at. Yeah, so we'll start with module 3, and then we'll just keep going. So global infrastructure. Let's go ahead and dive into this thing and start talking about it. So, okay, AWS Global Infrastructure, what is it? Well, in a nutshell, it's, AWS regions, availability zones, and edge locations. And so let's talk about global infrastructure. It's designed to be flexible, reliable, scalable. In a nutshell, you can see all these different regions in the world: Northern California, East Coast of California. East Coast of United States, South America, Europe, Asia. All these things you can use to build a global infrastructure day one. And that's one of the great things about using AWS. And in particular, one thing we should define is what a region is. And a region is a geographical area. And so you'll hear this a lot in exams. And so a data replication across regions is controlled by you, though. So you don't have to have it done automatically. Communications between regions use the backbone infrastructure. So really, really fast. And regions also have full redundancy and connectivity to the network. And a region usually has at least 2 availability zones inside. And so the idea here is that those availability zones help you also have more of a reliable system. And so why would you pick a certain region? It could be data governance. So we know European Union has different laws, proximity to customers, services available within the region, costs. As I mentioned before, that a region has multiple AZs or availability zones, and an availability zone is actually a fully isolated part of AWS. There's 69 of these AZs available, and they consist of discrete data centers. They're designed to be fault tolerant. They're interconnected, and you can choose your own availability zones. And Amazon does recommend replicating the data and resources across AZs. So what this means is that in practice, if you had a database, for example, you would want to replicate it across at least a couple AZs so that in case there was some problem, I don't know, a dump truck flips and then crashes into, an availability zone and it goes down, you would have automatically the data in the other AZ and there'd be in theory no outage. So AWS data centers are designed for security. And this is where the data resides and data processes. It has redundant power, networking, connectivity. In typical, a data center has 50 to 80,000 physical servers. When I worked in film, when we had some of the largest supercomputers in the world, we had something similar, but that was just one data center. They have, again, 69 plus of these, because an AZ could be more than one data center. And so you can see they have a lot of machines available. And AWS provides a global network of 187 points of presence, 176 edge locations, probably more, right? Like you can assume it's always a little bit more because they keep growing. They also have a global content delivery network, or a CDN, which reduces latency. And the reason you'd want to use something like a CDN, a lot of people ask me this when I'm teaching this material, is that if you push the content to all these locations in the world, no matter where a user is at, they'll have very low latency. So this is a fundamental law of physics, is speed of light. And so you must have, if you want latency to be low, the data must live close to someone. You can't make it faster, by any other means. You have to physically co-locate it next to, where you're at. And so by doing this, you actually get great performance locally. The infrastructure features, there's elasticity and scalability. They're also physically distinct. In an availability zone, there could be, again, multiple data centers, and they're physically distinct data centers. But there's backup generators, network connectivity, UPSs, cooling equipment, fault tolerant. So it's really designed to be scalable and decentralized. So the main buzzwords here to be aware of are regions, right? Those are geographic availability zones, are the coordination of the resources inside, and then you choose a region based on your compliance requirements. Okay, let's talk about service and service category. So AWS has, in terms of foundational services, compute, which is virtual automatic scaling and load balancing, networking, and storage. And then in terms of the category of services here that we're going to talk about is cost management, networking, database management and governance, and security and compute. So storage, this is a good one to be aware of and probably memorize, is that there are multiple storage services, but fortunately they're so distinct that it's fairly straightforward to differentiate between them. The first one is S3. That's actually the first storage service they've ever released, and it's object-based storage. What that means is that it's really designed for things like media files would be probably the best example. So you can put, I believe, up to a terabyte of size of a file inside of S3. So the good news is that it's huge in terms of what you can put there. What the limitations are that you can't incrementally update it. It's not like a database. Now, block storage, what that refers to is physically attached storage to a compute instance. And so with EBS, you can't mount the same volume across multiple machines. That's the limitation that it has. EFS is actually very unique in that it's network storage. So it's basically managed NFS. And with NFS, that stands for Network File System. And what the advantages of this is that you can actually access the storage across all the nodes in your ecosystem. This is fairly new in terms of a service that AWS is offering. Personally, I think it's one of the most exciting services, and I believe that we're going to see more and more of these network systems or network file systems. Glacier just is the archive. That's where you archive things. Okay, in terms of compute, let's break these down. We've got Amazon EC2. That's just the basic virtual machines that you rent. EC2 auto scaling. This allows you to auto scale maybe machines around a load balancer. ECS is their container service. This is something that's their own container management service. It's not Kubernetes. That's a separate service. Amazon EC2 Container Registry, or ECR, is where you can push your own private or public containers. And so anything that's container based on AWS, you need to push it first into their ECR. Elastic Beanstalk is a platform as a service. So it's a little bit of a legacy product in that it's very heavyweight. But if you do have things that are, more legacy oriented in terms of you need a VM and they need to be behind a load balancer, Elastic Beanstalk works reasonably well for that. The newer kind of things here are AWS Lambda, which is serverless. And I think the big distinction I'll mention with why would someone care about Lambda if you have Kubernetes is really, to me, more about automation versus performance. The performance is not great, but just like you can get a T1 micro instance and play around with it, it's really about the automation, right, behind AWS Lambda, because you can hook it into all these different events. Now, Kubernetes is very interesting. Their EKS system, Amazon Elastic Kubernetes Service, and the reason why it's interesting is because of the fact that they manage the complexity for you. And I think this is really the direction that we're going to see people headed to in terms of Kubernetes. We also have AWS Fargate, which is a managed container as a service as well. Okay, what about database categories? So in terms of database categories, we've got RDS, which is really their classic, managed relational database service. That was the first thing they came up with in terms of managed databases. Then there's Aurora, which is really kind of like a supercharged version of RDS. And then you got Redshift, which is data warehouse. And then you have Amazon DynamoDB, which is a key value store. There's even more. There's even Neptune, which does graph databases. But in particular, those are the main categories. Now, in terms of networking, these are key terms to be aware of. We've got, for example, Amazon VPC. This stands for Virtual Private Cloud. So this is where you arrange everything in a logical, topology so that everything is talking to itself, but not talking to the outside world. We have Elastic Load Balancer, which allows you to scale traffic based on metrics like health or, CPU or whatever. There's CloudFront, which is the CDN. There's AWS Transit Gateway. There's Amazon Route 53, which is managed DNS. There's AWS Direct Connect, and then there's AWS VPN. These are the main categories of networking. In terms of security, compliance, we've got IAM, which is really how you would set up users and groups. You've got AWS organizations, which are things like Active Directory-ish, essentially a topology for the security in your network. You've got Cognito, which is an authentication service, so you can assign that to potentially your web applications or mobile applications. We have AWS Artifact. We have AWS Key Management Service where you can manage security keys, and there's AWS Shield, which helps with security for web applications. In terms of cost management, you've got AWS Cost and Usage Report. You've also got AWS Budgets and AWS Cost Explorer. In particular, I would say if you're first starting out with AWS, I would recommend using a budget. That's probably the best possible day one thing you can do is set up like a $1 budget so that you get an email if there's a problem. Later, you also, I would recommend you look into the Cost Explorer and make sure you don't have like some machine running somewhere. So those are really probably the big things that I would recommend starting with. In terms of governance, we have the management console, which you definitely should, be aware of. You have AWS Config, CloudWatch. CloudWatch is for a lot of different things, but basically for dashboards and logging. You have AWS Auto Scaling, AWS CLI. So I am a huge fan of the command line, and I do recommend using AWS Cloud Shell with the CLI and using their default tools. You have AWS Trusted Advisor, which is really like gives you warnings for, hey, don't do this, do this. And then there's AWS Well-Architected Tool and AWS Cloud Trail. Now, Cloud Trail sounds like CloudWatch, but they're very different services. Cloud Trail is a security and compliance tool. So it shows you every single API call that has been made in your system. And in fact, it's really helpful to make sure that nothing weird is going on in your system. You should look through the API calls, regularly and just make sure everything looks the way you think it should look. Okay. Management console here, just a few things to pay attention to. I would just play around with it. That's the main takeaway. Okay, let's move on now to, let's see here, module. Let's double check where I'm at here. Okay, let's go on to cloud security next, which is module 4 here. And in particular, this is a big one for all certifications. And so the number one thing to be aware of, if you could only remember one thing about AWS security, is the shared responsibility model. In a nutshell, what it means is that AWS is responsible for some parts of the system. You don't have to be managing that at all. So for example, the best example I can think of is the physical data center. They take care of it. You don't have to manage it. You don't have to hire a security team to manage it. They handle it. You, though, as a customer, you must be responsible for your own customers' data. If you think about it, it's impossible for the business logic to be managed by AWS, right? Unless they wrote the application themselves, how could they possibly manage it? Ultimately, you have to manage that yourself. In terms of security of the cloud, they manage things like physical security, control need-based access, hardware, software, network infrastructure, virtualization, all stuff that's super tricky. They handle it for you. In terms of the customer, though, you have to manage things like patching the OS, passwords, security configurations, firewalls, account management, in terms of the infrastructure as a service, it means that you have to manage a lot more yourself. It's cheaper, right? Infrastructure as a service, but you have to manage it. Platform as a service is a lot nicer in my opinion because they handle a lot of the stuff for you and you can focus more on the business logic. Now, in terms of software as a service, one of the things to be aware of here is that the software is centrally hosted. You don't have to manage infrastructure that supports the service. So even better in some situations, like for example, if it's extensive monitoring and logging, I would argue why do that? Just use an agent like Datadog or New Relic, just have them do that for you. And then you don't have to manage that yourself and write a bunch of custom software. Okay, so I'll just go to the next section here, which is identity and access management. So a few things to be aware of here is that the IAM system is managed basically from the console, and you can, with it, control who can terminate, for example, an EC2 instance, and you can define fine-grained access, like who can access a resource, which resource, and how resources can be accessed. IAM doesn't cost anything. The essential components would be an IAM user. This is a person or application that can authenticate. There's a collection of IAM users. That would be a group. There's a policy, an IAM policy, and this is a document that defines which resources can be accessed and the level of access. There's an IAM role, and this is for you needing to grant a set of permissions for service requests. So when you define a user, you also get to define what are the things that they should access. And this is an easy one, I think, to mess up on initially, is that I think to start with, I would recommend you don't give people programmatic access because they probably don't need it. And I would wait on that so that those keys don't accidentally get leaked out. So basically programmatic access is something you can essentially maybe put off for most users until they ask you for it and then set up fine-grained controls. The MFA is a very good idea. This is two-factor auth. So you can create a token, you can install it on a mobile app, or you can get a physical like key fob, and it actually allows you to do two-factor authentication. And I would highly recommend that. So authorization means which actions are permitted. So basically after the application is connected to AWS, you say, what can you do, right? Can you launch instances? Can you talk to S3 buckets? The authorization means like who is the person, right? So it allows you to determine which resources or operations are allowed. And so the best thing to remember is this concept of PLP, or principle of least privilege. You'll hear it all the time. And that's probably the number one thing I would recommend with AWS. Remember PLP in terms of security, other than the shared security model. An IAM policy is a document, and there's identity-based and resource-based. Identity-based is a policy that corresponds to a user, group, or role. A resource-based is attached to a resource, like an S3 bucket, for example. So you can control either one. And so there's an explicit allow, or there's an explicit deny. An explicit deny takes precedence over an allow. Identity-based policies are attached to user, group, or role. So resource-based policies are attached to a resource. And how does an IAM determine permissions? The first thing is the permission explicitly denied? Yes, then it's denied. If it's a no, then the next thing is the permission explicitly allowed? Yes, then you can do it. No, it's denied. An IAM group is a collection of IAM, right? So this is really a way of collecting privileges for a certain group. A role is something you would attach to, let's say, AWS EC2 or AWS Lambda, and so you let that resource do the things for you. An example of IAM role would be that an application that runs on EC2 needs to access an S3 bucket. That would be a perfect example. Okay, let's talk about securing a new account. This is a really big one. In fact, I've seen this go down many times in a bad way, is that you must have the root user locked down in a production environment. Now, if you're just demoing it and playing around with it, I personally, am a little more cavalier about that because of some of the things I do. But if you're working in a production environment, you do never use the root user, because all it takes is if that root user's credentials get leaked, then they can take over your entire account. So the first thing you should do is that you should log in with a non-root user and use that account. So basically stop using the root user as soon as possible and create an IAM group and give that an admin privileges, disable and remove your account root user access keys, enable a password policy for users, and then sign in with your IAM user credentials. Store your account root user credentials in a secure place. So securing a new account, MFA, definitely you want to enable the multi-factor authentication. The options are a virtual MFA, so Google Authenticator. There's also UTF security key device like a YubiKey, and there's hardware MFA, so key fob. Securing a new account, so CloudTrail does audit everything that's happening, like every single API call. Very good idea. And I would definitely enable the logs beyond 90 days as well. You can also enable a billing report. So this allows you to just check out that nothing weird is happening. People aren't doing Bitcoin mining in your company or whatever. And really the best practices are secure with MFA, delete root user, create IAM user that's admin, and then control from there. Have groups and do PLP. Configure strong password policy, delegate using roles instead of shared credentials. Now, this is a very subtle one, but I think it's really easy to be like, oh yeah, well, we just create this user and then put the API keys onto a machine. But if you think through this, there's a lot of problems with that. For example, what happens if somebody gets fired in your company? Boom. Now you got a problem, right? Because you have to go into production and delete all those credentials. It's a nightmare. That's why role-based privileges are so much better, because they're assigned to the resource, and then the resource isn't aware of like somebody's API keys. So really API keys on compute instances are a very bad idea. And that's what they mean by delegating using roles versus the user permissions, and also monitor using AWS CloudTrail. And I believe the last one we'll talk about is securing accounts here. So AWS organizations is a really good idea as well if you want to consolidate multiple AWS accounts, and you can actually control things with the organizations. You can set up service control policies for a centralized control of an account. You can also do things similar to IAM policies. And the key management service, or AWS KMS, allows you to create and manage encryption keys. So this is a really good idea as well for if you're working somewhere where they have high degree of data governance requirements, that you would actually control the use of encryption across AWS services, integrate with AWS CloudTrail to log it, and then make sure your hardware security models are validated by federal information processing standards to 140-2 to protect the keys. Cognito is a service that allows you to do user sign up, sign in, and access control to web and mobile applications, scales to millions. I've actually used this many times in organizations, and pretty cool. It also has social identity providers as well if you want to use those to allow people to authenticate. AWS Shield is a managed distributed denial of service protection service. So it protects you from people trying to attack your site with a distributed denial of service. It's got safeguards for applications running on AWS and provides always-on detection and automatic inline mitigations. It's standard, and the advanced one is an optional paid service. You can use it to minimize downtime and latency. And then what about securing data? This is where you're going to get hammered on every possible certification exam. You must know these principles. So the encryption of data at rest. The encryption encodes the data with a secret key, which makes it unreadable. Only those who have the secret key can decode the data. The AWS KMS can manage your secret keys. AWS supports encryption of data at rest. So basically stored somewhere. Data at rest means the data stored physically on disk or on tape. You can encrypt data stored in any service that's supported by AWS KMS, including S3, EBS, EFS, and RDS. Encryption of data in transit. So this means when you're sending data back and forth somewhere. What you want to do is use transport layer security, or TLS, formerly called SSL. You want to do HTTPS to create a secure tunnel. And so a good example of services that support data in transit encryption would be EC2 to EFS, that's encrypted, maybe a storage gateway to S3 that's encrypted. Securing bucket and objects. Newly created S3 buckets and objects are private and protected. When use cases require sharing data objects in S3, it's essential to manage and control the data access, follow the permissions that follow the PLP, or principal of least privilege, and also consider using AWS S3 encryption. Okay, how do you make sure your system is in compliance? And in order to do that, you would want to make sure that you can look at things like the ISO 27001 or the EU General Data Protection, GDPR or HIPAA, and also look at frameworks. And so how would you do this? Well, one of the tools you can use is AWS Config, and it allows you to assess, audit, and evaluate configuration of AWS resources. You can use this for continuous monitoring of configurations. You can also go in and automatically evaluate recorded configs. So really, AWS Config is a pretty cool tool if you're into data governance, which is a really hot trend. And in fact, it's a job title. AWS Artifact is a resource for compliance-related information. So things like providing access to security and compliance reports. You can access downloads. And really, in a nutshell, cloud security is a huge deal for anyone taking a certification on AWS. So you want to make sure you can recognize the shared responsibility model. Remember that AWS manages the data center, for example. Make sure you identify the responsibilities of customers of AWS. Recognize IAM user groups and roles. Know when you would use both or either of the three. Describe different types of security credentials. Identify steps to securing a new account. Make sure you explore IAM users and groups, and also understand how to secure AWS data. Remember, principle of least privilege, encrypt and rest, encrypt and transit, and then also know about these compliance tools like AWS Config or audit, the audit trail tool, AWS Cloud Trail. All right, so this is probably a good spot here for today. We went about an hour. So in a nutshell, one of the things I would recommend is, if you want to keep going through this material with me, is just follow along with, if you've missed one, just go back to one of the other videos or podcasts and listen to it. I'm going to make it fairly usable in terms of listening to it passively. If you want to you're on a long drive somewhere and you want to study for the exam, you can listen to this kind of content as well. So hope to see you again for episode 5 next week. Again, it's going to be at 3 p.m. Eastern time. I'm going to keep this cadence, and see you next time.